Good morning, good afternoon, good evening. Welcome everybody. Happy to kick off a live stream. It's been a little bit, but more importantly, you don't have to have just me on the stream. We've actually got a full crew of folks. So let me go ahead and bring up everybody. Hey, there we go. All right. So why don't I let everybody introduce themselves? Teen, you're in the top on my view, so why don't you go ahead first? Teen, you there? Can you hear me?
Yep.
Okay, perfect. You want to go ahead and introduce yourself?
Yeah, sure. So hi everyone. My name is Tim. I'm a security analyst at eShard. My day-to-day work is mostly focused on mobile security pen testing and reverse engineering, with a particular interest in any devices that leverage the ARM architectures, and also design trainings on mobile app pen testing and reverse engineering to help teams ramp up. And for this session, we are going to switch gears a bit, and we'll be looking at Windows and x86, and we'll be showing you the initial integration of our TTD backend with Banner Ninja.
And then Xusheng, why don't you go ahead? Oh, excellent. Thanks, Lucky, for confirming you can hear. We have been having audio issues this morning. Josh is here too. Yeah, go ahead, Xusheng.
Yeah, so my name is Xusheng, and I'm a software developer at Vector 35, and I particularly work on our debugger, and I have previously integrated WinDebug TTD with Spider Ninja, which is welcomed by our user. And today we have we're going to present you our latest integration with esReverse, which is also a TTD solution that we can record the full system execution and then replay it, and we can integrate it in Binary Ninja.
I'm gonna go ahead and boost the volume a little bit. We'll see if that makes it a little bit better. Let me know if it's too loud, starts clipping or something. Yeah, and actually before we kick that off, let me switch back real quick. Features that we have, like for example with WinDBG, which we demoed on the last feature stream. So we should get some of the really cool, neat extra features are slowly being worked on. We've been friends with them for a while, and so it's nice to continue to do this. And so this hopefully is the first of many. This will be kind of like the intro functionality. So with that, welcome, Mathieu. Let's kick it over to see if I can pull up Xusheng's desktop. All right, so I think Xusheng, we're looking at your desktop showing Binary Ninja. Oh, the audio drop again.
Yep.
Oh yeah, the audio might have dropped. Sorry about that. Is it back?
No, I mean I can hear you all the time.
Yeah, you can. The people in the stream are giving me feedback about the volume level, so I just want to make sure we're okay for them.
All right. Yep. All right. So shall we just go ahead and introduce what is esReverse?
Yes, I totally forgot. In fact, actually, let me switch back here because first we're going to go to Teen. Teen's going to talk about generating traces, what esReverse is, and then we'll get to the your desktop. I'm a little tired. I didn't sleep very much last night.
So yeah, basically, esReverse is a platform that we use to manage projects, and we have different tools for reverse engineering purpose there, like Binary Ninja, and we also have our TTD solution, which is called the esReverse. And basically, esReverse allows you to do a full system recording of a system, like for instance Windows. So unlike classic WinDBG debugging, our TTD tool can do full system recording, which includes kernel and userland processes. And then the idea that we have is to have Binary Ninja to consume that trace as if it was a live debug session. So the first step that we have to do, but I'm not going to show it in detail right now. It's going to be for next live stream. But the first step that you have to do is to record the process that you are interested in. So to showcase the TTD capabilities, we have chosen Petya, which is a well-known old ransomware. And so it's a 32-bit process that we have run on 64-bit Windows. So basically, we run the ransomware and we record everything until we have a blue screen. And then from there, we have a trace that we can navigate through. And we're going to show you exactly how to do it with Binary Ninja.
And it's worth pointing out, I actually haven't looked at the latest esReverse in a little while. I used it a long time ago, and it was a separate standalone application. So I think it's also worth pointing out that you've got like the whole web UI. It's integrated. There's a whole platform that it's a part of now too, which is pretty cool. I mean, maybe that's other people in the stream might be familiar with that, but if you've seen like Tetra and Revan in years past, it's had a lot of changes and. As a part of now being esReverse. So some folks might have seen that in the past, and that's just a minor point to make about it if they're not familiar with it. So yeah. So yeah, you've generated the trace already. You said it was not Petya, a malware family that folks might be familiar with. And Xusheng, then we can switch over to your machine, I guess now, or.
Yep, you can switch over to mine. And I can show people how to work with it. So you guys are seeing my screen already?
Scenario manager?
Yes. So this is the ES-driven or esReverse web UI that Jordan just mentioned earlier. So the whole thing is running on a server. It's a small machine in my place, and you actually interacted with a web UI. You can see the URL here. It's a locally hosted instance. So we do have, so the scenario is like each scenario is like one recording or one trace, depending on how you like to call it. And today we're going to, I have 3 traces here, a hello world, which is very simple one, and also the ransomware Petya, and also another CTF challenge that we can show later. So we can start with this one. So I already have it fully analyzed, replayed in esReverse, which means right now the access to the trace is extremely fast. So I already started the Revan server on port 14,000, and I also, so this is the action UI that comes with esReverse, is showing like the code that has been executed and also the registers and also the stack tree. If you have used a debugger, you're probably already familiar with it. So this UI is definitely very usable, but the problem is it doesn't actually integrate very well with just like maybe in Binary Ninja, because in Binary Ninja you have all of the types, you have all kinds of things that helps you. But right now here you can only view a linear dump of the instructions. So the 2 teams, the eShard team and the Vector35 team, decided we want to actually integrate the 2 so that you can actually replay the trace in Binary Ninja's debugger. So that is where we started. So to do so, basically, as of now, you have to log into the Docker that is running the service and run the command, basically spawn the GDB server from the command line. But I believe in the future we can probably simplify the process of starting this GDB server, and it probably can also be done from the web UI, so that you don't have to really worry about this stuff like this. So if you are familiar with our Windbug TTD integration, there are a few differences with a full system integration like this. So to start with esReverse, you get a trace of the full system. So we have multiple programs here, and of course, in this particular case, we'll be interested in the PID 2212, right? So that is the actual malware we have that detonated. But we can also debug other processes if we want. And also we even have kernel code. So I will later show that we can actually debug the code in the kernel with ease. This is not possible with Windbug TTD because Windbug TTD is purely a userland tracing solution. So it doesn't actually give you the instructions that has been executed in the kernel. So let me put in the PID here, 2212, and also, okay, so the server is running. Let me go to Binary Ninja right now. So the first thing you want to do is to, of course, open the binary and get it analyzed, which I already did. And then the next thing you want to do is to switch to the debug adapter to esReverse. So this is the specific debug adapter that I wrote for the esReverse integration, which can talk with the GDB server I just spawned, and also then we are ready to basically connect to it. We put the IP address here and the port, which is nothing special really. So we're ready to get started. Cool. All right, so we have stopped at the entry point, the start of the binary, which is just the place where it starts. So we still see a familiar debugging interface. We have registers, we have breakpoints here, we have the loaded modules here, but it's also interesting that there are a couple of differences. Is the font good enough to see? Should I actually enlarge it a little bit? Or
Yeah,
is it
we're
good
getting
enough?
some bitrate issues, just packet loss, unfortunately. So I think it might have actually I think it's a little bit better now. Might just go a little bit. Yeah, let's go a little bit bigger. And then when you change scenes, it might take a second for the like to get a good iframe. So yeah, I apologize. We'll figure out a higher resolution streaming thing last time. Juan, the video is not it's not you. It is us. It is somewhere along the many steps that we're doing. So sorry about that. Welcome, Lionel.
Yep. So one of the things you will see is that we not only have all of the userland modules and DLLs, which is expected, but also we have kernel modules. So you can see here we have a lot of drivers here. That is usually not possible with WinDebug or other solutions, because when you're doing kernel debugging, you usually only see the kernel modules, all of the sys files. When we are doing userland debugging, you only see the DLLs. And if you want to debug something that interacts heavily from like the user program actually interact heavily with the kernel, it might be a little bit challenging to debug in WinDebug. But with esReverse, you not only have a trace that is deterministic, you can go back and forth. You can also just easily, debug it as you wish, because, we can. It's a full system record and replay. So there is no differentiation between the code that is in the kernel or in the userland. It's just code that has been executed in the virtual machine. So we can just debug them in whatever way we want. And also, so if you're paying attention close enough, you will see that we are actually analyzing a 32-bit binary. You can see here the platform is Windows x86, but it's actually reporting registers as REX, RBX, etc. So this is actually not really a bug, more like a workaround we create, because we are actually recording the trace on a 64-bit system, right? So the registers are actually physically 64-bit, although in this particular process, it actually is 32-bit.
Yeah,
Or at
until
the
you step
moment,
into the kernel. Yeah, exactly. Then it's going to go back to 64, right? Like,
yes. So that is why we actually present them as 64-bit registers. Also, particularly, you can see only the values are only having their lower bit set. That is just a new situation where the traditional modeling of the debugger doesn't really handle very well. Like the
yeah,
switching between the
time to
architecture
design new
isn't where.
UIs for that or something. Yeah.
Yeah. Now, of course, we do have all of the familiar functionalities. We can just step into this function. Yeah, it takes two clicks. I don't know why. So you can step forward, just like you can do in any debugger. But if this is your first time seeing TTD, you will be surprised because we can actually go. You can see. You remember the RIP value is like ending with 9309, right? We can actually do step into backwards, and it will go to the previous instruction, and it will just update to the previous status of all of the registers, stuff like that. So this is actually already giving you a lot of advantage because you have a deterministic trace, and you can just go back and forth easily and see things happening. So now this particular binary is actually obfuscated because I did some markup. So the main function is okay. So this is another interesting thing you will notice if you use this integration, which also surprised me a little bit initially. So when you're using a regular debugger, let's see whether you're using WinDbg or LDB, you would expect the bytes to be already readily available in the main function when basically the binary starts execution, right? But in esReverse, that is not always the case because this particular range could be paged out. I mean, when this instruction starts execution, when the byte set here starts execution, it could actually go into the page fault, and then the page fault handler will load the bytes and give you the actual byte. So right now we are in security init cookie, which is still before the main function is executed, right? So if I put a breakpoint here and let me resume it, and it will hit the breakpoint here. Okay. Where does it go to?
In the workflow machine. It switched to the workflow machine view. That's weird.
Yeah, but it actually switched to some 64-bit code. I'm not sure what's happening. Might be some bugs. Please bear with me. So what I wanted to show you is basically as soon as you actually when the execution actually gets to the main function, the bytes of the main function will be available, and you can actually really just interact with it normally. Okay. Let me do it again.
Do you just need to reconnect the session once you do that?
No. I just respond the GDB server to make sure it's the cleanest possible status, and it doesn't actually interfere with other things.
That makes sense. Yeah. So lucky sorry to interrupt. Lucky to answer your question. Correct. Binary Ninja has essentially a bunch of UIs and APIs to act as a TTD client. But some other backend has to actually implement the recording and support like the backward forward, memory read, all the different APIs. And so you can look at the connectors that we've implemented. There's a couple of different ones that Xusheng's been working on, and they're all in the open source repo, which I'll put a link to in chat for the debugger. So you can also add your own. But this is essentially us demonstrating the eShard integration, which is the first like whole system TTD. So we've had like RR and WinDebug TTD in the past, but we've never had something that could do like a complete whole system until now. So that's what makes this one.
Yeah. Okay. Yeah. I'm sorry to interrupt you. I didn't mean to. So basically, we have a handful of API, maybe 10 or something, that a debug adapter can implement to support time travel debugging. And right now, we have integration with WinDebug, TTD, and also we have a few others, like RR and a few others. And today we're demonstrating the integration with esReverse. It's just a full system solution, and it's very, very cool. All right, so I see the problem. The problem is actually this binary is manipulated. So it actually takes a legitimate binary, and if I remember correctly, it's actually alternating its content. So the execution actually never gets to the main function, and you can see the main function actually does not really appear to do anything special. So the secret here is one of the function I remember is I gave it a name. Yes. So
is it self-modifying? Is that why we're seeing like bogus?
So all of the important code is actually implemented well before it gets to main.
Yeah,
I think
during
it's
like
in some
initialization.
initialization. Yes. So so earlier I tried to put a breakpoint in main and try to resume the target, and it just haunts. It's probably a bug in our implementation, but that is caused by the fact that that instruction is never executed. So it just seeks to the end of the trace, and maybe do not really know how to continue, and then it just stops there. So this is a bug, but
kind of makes sense.
anyways,
Yeah.
it just actually, it's because this instruction is never executed. So this was a compiler generated binary, and all of the important things are in the main function, but the actor actually modified it and injected their own malicious code in one of the initialization routine. And once it does that, then it will just do all of the payload and reboot your system, and never gets to execute the main function.
Yeah, it's a great anti-analysis technique.
Yeah. All right. So it does. Now, of course, we're not going to show you how to actually analyze this binary step by step. But here is one of the common things you can do. Is basically you can see it actually has a call to virtual log, which, I mean, given this is a 2016 binary, so it doesn't actually try to, try its best to obfuscate the, the
imports.
function they're called.
Yeah.
So we can put a breakpoint on virtual log. Just press F2 here, and it will see a breakpoint is placed. It's inside of kernel 32, blah, blah, blah. And we can just resume the target.
And it's worth noting that you're in the raw memory view. It says disassembly view, doesn't show it because we haven't actually executed that as code. So Binary Ninja doesn't disassemble and decompile when you're in a debugging session. It doesn't do it across the entire bit of memory because that would take forever. So it waits for your execution to actually go there. So that's the reason you're not seeing a function at that offset. Like you can actually see obviously the disassembly bytes right there, but we could manually trigger analysis and create a function there, but we'll also, when we hit the breakpoint, it should actually just do it for us. I think that's my guess. So Xusheng.
Probably, I think that's fair. But anyways, what we're going to do is I will resume it, and it will execute, and it will hit the breakpoint here. And when that happens, there will be a function, as we'll be seeing. It might take a little bit to get there, because the ransomware might be, waiting for some time before the execution actually starts, which also takes a little bit. Yeah, here we go. So when the execution actually gets here, it will of course create a function. So we don't have a stack trace as of now, which is kind of unfortunate for today. But we can easily stack backwalls because we're actually at the first instruction of virtual alloc. We can just easily step into backwalls and get back to the callee, and this callee is surely inside of the Patia code, and you can see it's actually calling EBP, which this is actually interesting. So I thought it actually calling the virtual alloc in the IAT, but it's actually not, because you can see here it's actually calling EBP, and EBP is of course dynamically resolved because it actually contains the address, right? So I was kind of confused because I thought it doesn't actually really do a good job protecting itself, maybe because it's 2016 malware, but that is just what it appears to be. It actually does dynamic resolution and protects itself very well.
Well, and that
right?
makes sense. You said it was a normal binary that was compiled, and then they went and patched things in and modified it to put the initials, code in the initialization. So it's entirely possible the original normal functionality had the imports in there, but because you have the trace there, you're able to catch it. Anyways, there is a question, by the way, for Teen. John Black says, how is the emulation/TTD implemented? Is it QEMU? I know the answer to that. Yes, it is QEMU based originally. But the next follow-up is, would malware that does anti-QEMU checks behave correctly under esReverse?
Will malware that doesn't take checks behave correctly? Well, it depends. I think we can get detected, but then we need to set up the VM so that, and also the Windows image, so that we can bypass the detection.
Yeah, that makes sense. So I think there's like Skilla hide, for example, right? In x64 DBG, there's similar fingerprints you'd want to remove from QEMU. So I don't know. I guess the other question is that something that esReverse does out of the box, or is that just something that users could configure using the either an API or a plugin or something like that?
No, it's not done out of the box right now, and it's not really configurable through the UI. But you have to tweak the virtual machine and all the Windows image that you are going to use for your sample.
When you're actually, that brings up a question I'm curious about. When you're generating that TTD trace, do you have the ability to use is it pure hands-off at that point, or can you do like normal debugger operations like separate points, modify memory, do things like during the initial trace generation? If for this example, like you might want to be able to, maybe that's a feature request if it doesn't currently do it.
No, you can definitely do that. For this use case that Xusheng is showing you, we used an automatic mode so that the recording starts when the process is running, and then it stops as soon as you get the blue screen. But you can do more fine-tuned recording by using WinDBG in the backend. We can script. We can do some scripting with WinDBG to interact with the virtual machine when it is executing the process, and you can definitely change registers at runtime if you want to.
Yeah, I'm not even up to date right now on the latest QEMU detection breaks. I know for a while there's like shared memory pages at certain places or other kind of things. So I would have to kind of go poking at it. But for any capability that exists to detect something, there's that constant cat and mouse, right? Where you like detect, you avoid, you detect, you avoid, you go back and forth. So that makes sense. All right, sorry to interrupt, Xusheng. You can keep going.
No, I mean, this is a really good question, because if it gets detected and there is no way to counter that, then it will be useless. But the good news is with esReverse, you can actually somehow interact or customize the tracing, and you can modify the state of the target when during not really during the recording, but you can actually defeat some kind of detection or protection with the debugger, and in order to help you get a successful tracing. I think I don't know whether the esReverse have examples on this, but probably we have, and maybe later we can actually link to some of the resources here, because we're not really going to get into that today. So,
yeah, sure.
All right, we talked about virtual analog function, which is a really common function, and if your memory of virtual analog is not really vivid, this is a brief recap. Basically, it allocates a buffer with all of the protections, and here inside of here we can just do a step over. We of course want to first cancel this breakpoint, because otherwise if I step over, it will just go into the EBP, right? So I will just delete breakpoint here and do a step over. Yeah, okay. It says already hit the breakpoint. Maybe something is off a little bit. I don't know. So right now the REX buff register should actually hold the buffer that is allocated, right? Because virtual allocs returns the buffer when the allocation is successful. So what we're going to do here is we can put a hardware read breakpoint. Now this is what I actually created today. So I believe I'm the only person who have this thing. You guys don't really have this yet.
Is that
So
not pushed to dev? You're saying like that's still just a local test?
Yes.
Okay.
Yeah, I'm running a test suite here. You can see here, like the
yeah.
So we just put a hardware read breakpoint, and of course all of the breakpoints, like the software breakpoint and hardware breakpoints, is emulated by the GDB stub and the ES.
They're all software at the end of the day with that whole system emulation.
Yeah, but we're just following the tradition because people are familiar with hardware, breakpoint stuff like that. So we just use the term. But what actually happens is the GDB stub is actually just iterating over the recorded trace and find anywhere this particular address is read and the size matches this. So it actually doesn't really do the DRX register thing with Intel architecture. So that is what happens when you actually debug a live target. So in a esReverse or any TTD solution, all of these breakpoints are actually all emulated. It just creates the illusion that you have a breakpoint here and it is, but behind the scenes, it's all just emulating the thing and stopping or sticking to the point of the entire trace where So what I'm going to do now is just put a hardware write breakpoint here because the malware allocated a buffer to it, and it's very likely that it's going to do something to it, and I just want to catch where it is written to, right? So I will just add a hardware write breakpoint, and I will just click OK. And I can see here it's still a little bit buggy. Says software, but it's really hardware. But I will fix that before I ship it, so it doesn't matter. And I will just resume the charges. And let's wait a little bit. It says running, and the next time it hits, it should actually hit where we have the write to it.
That's actually a good question.
It's taking a little.
Well, I was going to ask you about like the performance of it. I mean, obviously when you're doing emulation in general, especially software emulation, it's going to be slower. So I assume that's the main cause of the slowdown, or is there like a lot of?
Well, my choice of the word emulation is basically maybe I should use simulation. It simulates breakpoints, but it's actually not really emulating anything. It's simulating a breakpoint hit or something. This is actually a quite large trace. You can see here is by length is by size is actually 258 gigabytes. Like the hello world thing I recorded is like only 3 gigabytes, and the other thing is only 7 gigabytes. So this is actually a really long trace. I suppose what happens is because the malware potentially waits some time before it executes, and these all get recorded as well. So that trace is particularly large. And if I remember correctly, so for the breakpoint to hit, it actually takes a little bit over a minute or something.
Something you could do also, Xusheng, sorry to interrupt.
No, please do.
If you look at the parameters that you provide to virtual alloc, at some point it is going to push ESI plus 50 on the stack to provide it to virtual alloc. And so this ESI plus 50 will lead you directly to the PE file format, to the DLL. And then, because we know that from there, it's going to try to find the entry point to the DLL. In Binary Ninja, once you jump into the location in memory where the PE file is loaded, you can retype it to see the structure of the PE file format.
Oh, that's cool.
And then see the entry point address that you can then just double click and you will jump into the DLL.
Yes, but I mean, it's already running, so I can't really interrupt it. Let's just wait a little bit.
Okay.
So this is a really large trace. So and I think also because the current implementation is more like a demonstration and proof of concept. So we don't really, or particularly the TTD stuff that we're interfacing with, where I'm running here, it doesn't actually really try to.
It's not super efficient.
Yeah, so we can actually make it better in the future, but more like we're just showing you can do these kind of things today, and it doesn't really be optimized.
Yeah, so just to continue on what Teen was describing, the fact that you can just basically like arbitrarily type raw bytes in memory and have it decoded, like show this like sort of structure decomposition in binges is kind of nice. So if you've ever opened up just a random PE file and scroll to the top of it where you can see like the headers, like you'll see it not only shows you the structures being applied there, but like pulls out the bytes and like splits them into the sizes and signed or unsigned or whatever they are, and shows you that. So the fact that you can use that here is nice. When anytime you've got any kind of like downloader or unpacker or like in-memory loader or any of these kind of like behaviors, you can just apply the type directly. In fact, I think a while ago on the blog we demoed for one of our releases just opening up some random bit of shellcode, and it was like when it detects like you getting like peb and teb at like FS30, it will just automatically apply the types at those locations of those structures, which makes it really convenient for analyzing little shellcode stuff like that. Hopefully I stalled enough that we've got some some progress on the UI.
It might be a bug here. I'm not really sure what's happening because when I tested, yeah, it says requested blah blah isn't mapped at the context, so it doesn't really work.
We got some sort of desync or some again, this is a couple of these features are very fresh and new, just implemented. And as Xusheng alluded to earlier, that we're going to continue to work on this, right? So not only on the testing side, but also on adding additional functionality like the module stack view, the stack frame view, for example, is another one that will be coming. So we only do demos live. We do it all live, and then this is what happens sometimes. It's not without.
Yeah, I didn't really test this before going to the stream. I thought I can just do this and just did this, and technically it should work, but maybe I just did it wrong or something. So
yeah, we can start over to the virtual alloc function.
Yeah, we can go to the virtual
Protect or alloc?
function, which I
Yeah, protect also.
yeah. So we can put breakpoint here, resume it, and it should hit. It didn't hit. Okay.
I noticed too, Xusheng, that it now does an analysis hold, which probably helps performance a lot. So if there's any kind of breakpoints, it doesn't wait, or it waits until you land somewhere before it actually triggers any kind of analysis.
Yeah, well, the problem with the performance is not really performance of us; it's the performance of the the trace staking, which
well,
probably
and the interface too. The interfaces could be somewhat us together, right? Having to actually the API, the GDB stuff is notoriously poor performance for remote debugging. We've a lot of implementations. So that could be a joint task for us to work on. Like I know, and I realized earlier I said that this is our first whole system emulation. It's not entirely true because we did have Corellium integrated, and we have the ability to interact with their debugging interface, and they also have a custom GDB stub essentially to try to improve some of the performance. You can do things like reading memory proactively, or like larger chunk reads instead of small reads of memory to like to load in things, which especially when you're doing a whole system, it can be a lot of performance like implications there. So I'm sure we'll have a little bit of work to do, but this is the first full system emulation that can do x86, x64.
So we are at a virtual protect call. So this happens before the virtual alloc. So what happens is basically the malware is trying to modify the permission on part of the binary before it actually decrypts it in place. So this part of the binary, right now it's shown as code, but it's actually just encrypted DLL or something. I can't remember. So basically, this part of it is actually really just a encrypted DLL. So what I'm going to do right now is I will set a hardware breakpoint on write to this address. Yep, and see when
is it decrypted in place? Yeah.
Yeah. Switch it. Oh, it hits this breakpoint again. My bad. This should. It's getting where.
I wonder if we're landing in the kernel. If there's something. I wonder if we're not able to render into kernel, because it looks like we should be. I think the kernel. Oh, check the memory map. Is that? Yeah, the single step knows that
we're in the kernel. I think it might be the case where the write to it is in the kernel. I'm not sure. I mean, I am not sure.
Yeah, it looks like, because we're in NTDLL plus some offset. So I wonder if this could be on the Binja side where I don't know how we've mapped in the kernel memory. Yeah. I mean, it should be.
So we this is actually already after the decryption.
Was NTDLL in that module list? I'm curious if it shows.
It's a little bit weird. All right, so well, I mean, I do have another sample that I know is going to work very well for sure. But although I thought this one should actually work, maybe my latest change introduced some bug. I don't know. It's kind of weird because previously when I tested with Tiana, it actually works. I don't know if I changed
If
anything.
you try to come back to virtual alloc and you look at the parameters on the second parameters, it should lead you right away into the PE file, as I said previously, and then you can convert it and look at the entry point of the DLL.
Right. So I know we can do that. I just try to want to give the user a more authentic view of what's happening because
Okay.
yeah, and of course, because we have everything annotated here. Like we have a pretty thorough analysis already. I just wanted to kind of recreate the experience of how we analyze it and
Could find it in the
with
first
this
place.
tool. Yeah, and find it in the first place. Well, of course, I can just jump to the place where it is decrypted and show people, hey, this is what happens, and of course, it will be fine. But anyways,
It is nice, and it's worth pointing out that even with the bugs and having to restart, you're still analyzing on a trace, right? So unlike having to run the binary fresh in a VM with remote debugging, if you were doing this live, that they'll have that whole trace is super nice. I do want to answer one question somebody asked in a different chat, which was, is esReverse a commercial product? Is it shipped with Binary Ninja? So no, it is not shipped with Binary Ninja. The only debugging engines that we ship directly we ship some WinDBG integration, not the core of it itself, and LLDB. But yeah, so both Corellium and esReverse are separate products where you would have a license for them, and then you can configure Binary Ninja to kind of work with them both. But it's not shipped with Binja or a part of Binary Ninja directly. So thank you for asking that question, Sergey, in Discord. If y'all are still apparently there's a live watch party going on over on the OA Labs Discord. So if people want to get the Mystery Science Theater experience for this of live commentary, you can go tune in there.
Let me use the backend commands directly at the breakpoint. Maybe the thing I just added today is buggy. I blame AI on that. Yeah, let me try it again. And like even if it doesn't work, it doesn't matter because we can show something else. But I just want to.
I know. You're an engineer and you built the thing and you want to get it to working. So I get that. Oh, secret voice chat. Oh, good. So you got to be one of the cool people there. All right. I apologize if I outed some secret. It was at least referenced, I think, in a public channel, if it is a private thing. But yeah, great Discord. Also, I know the Invoker folks. We got Josh commenting earlier is doing some watching as well too. So
yeah, okay. Let me switch to this different binary. So this is actually a CTF binary that eShard is using to host mini CTFs at a few conferences they go to.
wait, are we gonna spoil it then? Is this not a live thing anymore?
It is actually a spoiler. So this but I just kind of want to give the viewers a little bit help. Because so this is interesting. So eShard goes to multiple conferences every year, and whenever they actually sponsor the CTF, they have a table. Sorry, the sponsor the conference. They have a table. They organize the mini CTF. It's actually like a one challenge CTF, and you can actually come to their booth, and you can actually use eShard, esReverse, and Binary Ninja to try to solve it. And the winner actually wins a Binja license, or yeah, the fastest person that actually solves it wins a Binja license, if I remember correctly. So,
Yeah.
and this is actually the actual binary that is being used. So you guys actually get a little bit, spoiler by watching this stream. And
I expect some really fast times in the next race.
I don't think so, because what I'm going to show might be not really the hardest part. So I don't know. I mean, it's definitely helpful because it tells you how to do things, but you still have to,
Do the work. All right.
sit
All
on.
right. That's fair.
Yeah,
Good. That sounds perfect.
it doesn't. And of course, this challenges requires some dedication, and of course, we're not going to cover all the steps today. So I'm going to spawn the. Okay.
Yeah. Also, maybe in action, you can show quickly the frame buffer just to explain people how to use the binary.
Sorry, can you repeat that? I didn't quite follow.
Yeah. Sorry.
Maybe Xusheng, you can also show in action the frame buffer so that you can
Oh yeah,
navigate
yeah.
into the timeline and you can show how you run the binary for the first time. Well, how we run the binary when we did this recording.
Like just the GUI, the visual GUI. Is it available in
Yeah.
this interface
If
then?
you go, yeah, you go in view and then you show frame buffer.
Go back to the other one, yeah. So second menu up top.
Pardon?
Can you the view menu, the second menu, file, view, navigation up top, hit view. There you go, frame buffer.
Frame buffer.
Very top.
Oh yeah. So this is actually the window, the frames from the QMU that has been recorded, because this is what happens when so this is basically what happens on the screen when you actually do the recording, and can see the program is being executed, and also there is a WinDebug instance that is connected to it at the time of the recording. I don't know why exactly you have this open, but it's interesting.
Yeah, actually, Jordan, can you switch to my screen?
Yeah, absolutely.
Please, so I can show you.
All right, should be switched over. Let me know if the volume's still good and everybody can see it. I see you've got Binja in the main view, and then to the side you've got the esReverse disassembly.
So right now in the middle of the screen, you have esReverse.
Hold on, I think I'm looking at an old view. 1 second. Did your view refresh and I'm not getting it? I think you might need to restart your video sharing, or is it? Hold on.
Okay.
Sorry about that. I'm not seeing it.
Right now.
So I see Binary Ninja on the left and the main in the middle, and then the right I see esReverse. Is the only thing I see.
Okay. No, it's still not the right screen. Hold on a second.
Okay, yeah, I see it's disconnected. Let me switch back to all of us here. Oops. Doop. I'm gonna move over this way.
No, it's still not the right screen.
Oh, no, it's stuck. Let me see if I see anything on my side that I've done to freeze it or anything. Sorry, y'all. We're running into a bunch of bugs with Video Ninja today. I think we'll test a different platform for next time, because we're not.
So that's fine. You can come back to Xusheng view.
Yep.
All I wanted to say is that the screen that he showed you is well, the trace that we recorded for this one. It was another mode of recording. So as I said previously, when you record, you have different modes that you can use. The very easy one is everything is automatic, like it starts the recording when the process is running and stops the recording when the process is stopped. But for this, for the trace that Xusheng has, what we did is that we wanted to reduce the scope, so that we have used WinDBG to start the recording at a very specific moment. So that's why in the previous screen you could not see exactly when the
it just showed WinDBG like on the frame buffer, right? Like.
Yeah.
So how do you actually trigger that? Do you use it by like writing to some memory value that you're watching essentially, or like what do you use to trigger the starting and the stop? How does that happen?
You set a breakpoint with WinDBG, and that's the event that we are waiting to start the
Oh,
debugging.
okay. So you have like an event layer, and then the breakpoint is a specific type of event that on the outside, when you're emulating it, you can sort of catch
Yeah.
that. Okay. Cool. That makes
All right,
sense.
so I think I can continue with the demonstration of the CTF challenge.
Oops, I clicked the wrong thing. Sorry. All right, we're back.
So it has a pretty large main function, but we do have a write file function, a call to write file, and we can actually put a breakpoint here, and we just resume the target, and it will hit. And yeah, this is a smaller trace, so it just hits very quickly. And so in case you can't remember, RCX is actually the handle, RDX is the buffer, and basically we have a
There's a
PE
PE.
file here that is waiting to be dumped. The size is 22F0. So one of the feature I created, basically you can actually set the size of the selection to a fixed thing, and you can just then selection save to and save it to disk.
Oh, I didn't know about
This
the
is,
save to one. I knew about the extend, but I hadn't seen save to. That's cool.
Yeah, because one of the things you want to do while you're analyzing, let's say, malware is basically you want to dump things to a disk, and basically selection set size to and selection save to is what you want to use. So I already saved it to disk, and is actually this file. So
Kernel
now what
driver.
I'm going to show next is so we are actually so this binary is actually later calling device IO control to actually communicate with the driver. So what I'm going to show you here is basically you can actually debug the code. So let me so let me resume the target and get it to the place where the device IO control is being called. So by this time, the driver is already loaded. You can see where it is loaded, angry, blah,
The
blah,
.sys,
blah.
the
We
second
have
one.
yeah, we can actually use this to rebase the binary. Base, blah, blah, blah. And I already know device IO control is that I already marked up where is the device IO control, so we can actually just go back and I think we can actually directly jump to there, right?
Yeah.
Yes. Yes. So again, we haven't really created a function there because we only create the functions which is originally in the exe file. This is a function in the driver, which is, yeah. So, but you can actually see the bytes are the same because they are the same, right?
Yeah.
Yeah.
And just to note that you're rebasing. Yeah, normally if you're debugging something, you'll rebase automatically, but in this case, it's because you've separately opened the kernel driver itself. And so you want to line that up so it's easier to match. You might even be able to use the project linking feature actually to set up links from userland to the kernel there, I suspect. But
yes, that is totally possible. So ideally, we can actually integrate the analysis of the two so that when we are viewing something here, we can directly see the device IO control function is already here, and whatever markup I already did here can be, viewed here. But that is something we can do in the future. But right now, what I'm going to show you here is so you can see here right now we are in this place where we are about to call the device IO control, and I already placed the breakpoint at the device IO control function handler, which is this is where the major functions are set up. So if you're familiar with Windows kernel debugging, Windows kernels, you know that the device IO control handler function will actually run on the same thread of the user code that actually calls device IO control to send the request. And we're just going to see that. Yep, that is. I'm not really sure that's what I'm expecting to see.
Was that a single step or a breakpoint? Like what? Do we know why we stopped? Because it doesn't look like the breakpoint address.
Sorry about that. I thought I tested this and it actually worked for me.
I am wondering if maybe your recent changes on your test branch are actually unsafe, causing some other bug, I suspect.
Yeah, it could be the case. Let me try to use the regular one.
Anybody in chat have questions about either esReverse or Binary Ninja that we can answer in the meantime?
I just shared in the chat a link. So if anyone wants to play with the Hungry Pangolin trace, I've shared the link so that you can also play with the trace through our web UI.
I think it might have blocked you if you're not a moderator to post links. If you put it in our Slack channel, I can post it for you.
Okay, hold on a second.
There we go. Yeah, I didn't. Yeah, I think I have to switch to a different view to see the moderation settings, so it's not letting me approve it. Related, I'm actually curious if people that are watching have any suggestions for features they would like to see on top of TTD integration. I think there's a lot of cool new ideas and research. Like I was surprised when I saw some of the new query stuff that WinDBG is doing. I think exposing this to like an API and plugins and being able to do like automation on top of it's going to be really effective. I know I can't wait to see, for example, Binary Ninja Sidekick have better integration where you can have the LLM know how to navigate a trace and go backward and forward and pull things out, much like you would just a regular debugging session. So I think that'll be a cool improvement in the future. So definitely let us know if you have other ideas of things that we should be working on. And the answer is easy. It's just right there. It says you're a champion. That's all you got to do is just go right there, right? Teen, there's a question for you. Are there any starter esReverse licenses, like for personal, like just non-commercial users?
Right now, no, but we're going to provide a freemium version so that people can play, like the one you are just currently seeing with the link that you just shared.
Mm-hmm.
We are currently implementing a freemium version so that people can play with the tool. Right now, we just only shared one trace, which is Hungry Pangolin, but we are going to share more traces later.
Okay, cool.
Jordan, can you block my video a little bit because I figured out the reason why it's not working, but I just need to look up something in Slack and I don't want to really show
Not a problem.
that to
You're
the
off.
audience.
Yeah, your video's off screen. We have the three of us in video and Teen's frozen image, which is probably Video Ninja's fault if I had to guess. Probably not. Actually, I can switch back to my desktop. Actually, here I pulled up that link. Let me see if I'm doing this right. Make sure I carefully click this. All right, sorry about that. I found where the video wasn't working on this mode. So let me add that, and there we go. Okay, both our audio should be back. So this is the ttd.eshard.com website that I pulled up here. Time remaining. Oh no, where'd it go? It was there. We might be overwhelming the site now too. All right, let's switch back to you. You said we're good to go back to your screen, Xusheng?
Yep. All right. So, well, folks, I realized what's happening because I forgot to pass this single process include kernel option to the TTD stub because, as I mentioned earlier, this is a full system trace. It not only has userland code, it also has the kernel code. So by default, this option is not passed. So when you don't pass this option to the TTD server, it will only give you the userland code, which is reasonable because like when you're actually debugging some user code, you don't really want to go into like kernel dispatchers or whatever page fault handler, all of the kernel things that could potentially execute when you're just trying to debug some userland code, right? So after I add this option to the launch TTD server, when we actually resume the target, it will actually also replay the kernel mode code. And the thing I tried to show you guys earlier.
Teen, do you mind muting Teen, because your keyboard's very loud. It's kind of hard to hear Xusheng. Sorry about that. Go ahead, Xusheng.
Yeah. So basically, once I fix this, hopefully, ideally, it should actually just work.
Do you think this was the issue with the last trace as well when you were trying to go into virtual alloc, or was that a different issue?
It could be because these are all super new and not. Yeah, okay, he's not. So the breakpoint he's now, and we're actually in the kernel land. So you guys see here, we're still debugging this, and we're actually at this device IO control handler. And
we should line up with
the same thing at this time. Yeah, sorry, I just forgot to pass that configuration option to the code.
Yeah, so I think it's the same issue for the previous for the virtual alloc and virtual protect.
That makes sense. All right, well, good, easy fix. I like this is how people know we're doing it live. This is not a canned demo.
Yeah. So so this is so new because currently I have to literally just run this TTD server, command on the command line and log into the Docker, which I promise you is not going to be the end user experience because hopefully we will add some buttons you guys can click here so that basically you can spawn the TTD server here and have some nice UI buttons you can check. Whether you want to include kernel code, whether you want to debug a particular PID or something, you don't really have to, do what I did. So that's something that we will try to optimize for end users. But right now, it's basically, you can see here, we have a single process option along with the PID, which means
you might want to make your font a little bit bigger, by the way. It's a little small.
How do I do that?
Command Shift plus, or you can do that, yeah.
But it just goes outside of the screen.
Double click the title bar.
No. Let's just put it here in VS Code. Yeah, that's better.
Oh.
So, single process mode. Along with the PID. So basically this allows you to only replay the instructions in a particular trace, because although this is a full system recording, it's very powerful. You see both you see code from all of the processes and also user and kernel code. But sometimes, or even most of the time, I believe you would only want to look at coding in a particular process one at a time. So this allows you to actually spawn the TTD server with this particular PID in mind. And also basically you just configure whatever IP and ports. And then if you pass this single process include kernel, will also include kernel code. And if yeah. So we don't really have a stack trace right now yet, but after we have that, you can even see the call stack from all the way from the user at the device IO control into this kernel thing. You can see how Windows kernel actually dispatches the IRP and eventually it gets here. So I can actually show you here in the Action UI that how do I go to address?
You can, in the bar right below, you have search. There is a. Do you want to go to a specific address? Or?
No, I just want to go to the place where the device IO control. Okay, yes, it's here. So this is actually how it calls into this function, which is I think it's the same function we're looking at, right? Yeah, this is the place we're looking at, and so far our integration does not really replicate the call tree that the Action UI has. But in the future, we will have this same thing. And you can see actually, right now we are at here, and you can see it's coming from IOF call driver and IOP synchronous service tail, blah, 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 all the way up to whatever NT device control file. I believe this is where it goes from userland to kernel. And these functions, IOP, this is an interesting name. IOP XXX control file. Why? Anyways, this is where Windows dispatches this IRP and send it to this particular driver, who is responsible for handling this particular request. Which is really insightful, because usually you don't really see stuff like that. You only see a backtrace, which this is more like a normal debugger where you see the backtrace, but the call tree is more like it also gives you all of the siblings. And again, this is only possible because we're doing TTD, because we have the trace. We can
you have more context, yeah.
Analysis on it. Yeah, so one of the steps that enables this this efficient retrieval of the trace is basically there is a replace step, which esReverse has did all of the analysis, including the backtrace and call tree analysis, that is essential for a very efficient lookup for the call tree. That is one of their analysis that they run.
Teen, I have a question for you. Is it esReverse, esReven? Was it null name, new name? Are there different parts of it? Because I noticed we're kind of interchanging the names, and I want to make sure it's clear.
So esReverse is the platform that currently hosts Banner Ninja.
That's right. That's right.
So our TTD solution is called esReven, but it is hosted in the esReverse platform.
Thank you. I think I've known that. That's my fault for forgetting. So yeah, and that's actually a point too, that if people have esReverse, that was the web-based interface and the web platform, there is actually like a Binary Ninja module. So you guys are like our first actual, I think, technical reseller / integrator who is taking Binary Ninja. There are companies that use Binary Ninja as like a library and integrate it, but you guys actually like expose a kind of different version of it in the web UI for teams that want to use it, which is kind of cool. So that's another way that we've been working together, which is neat. But okay, thank you. That makes more sense. So esReverse is the entire platform. esReven is a module that does the whole system TTD, and then of course you can actually have Binary Ninja baked into esReverse as well. So all of those pieces make more sense now. All right, good. Thanks. Sorry, Xusheng, and you got 5 minutes left.
Just I think as a reminder. That's all for.
Yeah.
Yeah, I mean, I think we demonstrated the thing we wanted to demonstrate, although it's a little bit rough in the middle, but hopefully I still managed to show how this thing is powerful, especially when combining our analysis capacity with their TTD capacity. So definitely stay tuned. Wait for the announcement and maybe a future stream. And also, if you ever see eShard at any conferences you go to, try to solve this challenge because you already have a little bit of advantage. You see the drivers being dumped and you see how it works roughly.
Sounds like people should check
yeah.
out that URL as well, correct, team. That might also help them get a head start on that. So
Yeah.
perfect. All right. Well, thanks to both of you, and thanks everybody for tuning in. If there's any last questions, let us know now. Otherwise, of course, you can ping us on the Binary Ninja Slack. And in fact, a whole bunch of the eShard folks are on the Binary Ninja Slack as well. So yeah, I don't know if you guys we could even make you a separate public channel for esReverse questions if you would like. I didn't ask you that beforehand, so not to put you on the spot, team. We'll talk about it with the rest of the team later and see if folks want to do that. But either way, we're happy to take questions and pass them along if you guys have other questions about this setup. Thanks for hanging out with us on this. Is kind of like an early prototype on this integration. You can see we got there in the end, Xusheng. I think that was a good recovery, good find on the flag. So that makes sense. I think we're yeah, that was well done. So I don't see any questions, so I think we'll switch off back here, and yeah, look forward to seeing everybody back in a little bit whenever we get another round of things to show off. Cool.
Yep.
Yep.
All right, sounds good. Take care, everybody.
Thank you. Bye.